Chapter 2.1 Radical Functions and Transformations. A radical function has a radical sign with a variable in the radicand, which is the number under the root sign. Radical functions, some examples: f of x equals the square root of 5x. We have a variable under a root sign, so it's radical. Another example, f of x equals 3 times the fifth root of x minus 4. We have a variable under a radical sign, so it's a radical function. An example of something that's not a radical function, f of x equals x times the square root of 5. We don't have a variable under our root sign, so this is not a radical function. First example, sketch the graph of y equals the square root of x. Use the table of values. So we have a table of values. What types of numbers are we allowed to have under a square root sign? Positives. What happens if we have a negative? So let's try second square root of -1. We get an error. It says non-real answers. So if we have x of -1, then our y value will be undefined. You could also write error there. Okay, let's go back, pick some numbers that are going to work. So let's do y equals 0. Square root of 0 is 0. Second function, square root 0, we get 0. 1, the square root of 1 is 1. Y equals 1. I'm going to pick perfect square numbers to make my life easier, so I know that 4 is a perfect square. The square root of 4 is 2. There we go, y is 2. 9 is a perfect square. Square root of 9 is 3. Y is 3. 16 is a perfect square. Square root of 16 is 4. And since our graph goes up to 25, we'll do 25. The square root of 25 is 5. Let's plot our points so we can draw our graph. We have a point at 0, 0. We have a point at 1, 1. Point at 4, 2. We have a point at 9, 3. We have a point at 16, 4. And the last one's at 25, 5. Then we can join those points together. We see, based on the dots, the graph is going to curve more in the beginning, and then it kind of flattens out a bit. So that is our radical function, the base radical function, square root of x. State the restrictions on the radicand. What can we not have under the root sign? We cannot have any negatives, so we take what's under the root, which in this case is just x, and that thing has to be greater than or equal to 0, because we can't have square root of a negative. State the domain and range. Domain are x values, x such that, well, we just said x has to be greater than or equal to 0 because we can't have negative numbers. So x greater than equal to 0, and x is an element of the real numbers. Close the bracket. Range. Now the y values, y such that the square root of a positive value is always a positive value. So y is greater than or equal to 0, and y(er), the y values are elements of the real numbers. The graph of the base radical function has an endpoint at 0, 0. This is our endpoint here. So we have an endpoint at 0, 0. The parameters a, b, h, and k follow the same rules as they have for previous transformations. So just a reminder, here's how it looks when it's put into a radical function. So we have the a in front of the radical, the b is underneath, then brackets, our binomial x minus h, that's all under the radical. Then outside the radical we have plus k. What do those mean again? A is the vertical stretch, and if it's negative, then it's a reflection on the x-axis. B is a horizontal stretch, and if it's negative, then it's reflected on the y-axis. We have H is the horizontal translation or shift, and then K is the vertical translation or shift. Remember to apply stretches and reflections before you apply translations. Translations are always going to be last, so you shift last, SRT, stretch, reflect, translate. We can use mapping notation. Mapping notation, we start with the original point on the original function. When we apply all the parameters a, b, h, and k, we get x becomes 1 over b times x plus h. We can also write this 1 over b times x as x divided by b. Doesn't matter, so x over b, and then plus h would be the transformed x value. The y value goes from y to a times y plus k. Sketch the graph of each function using your knowledge of transformations and mapping. State the values of a, b, h, and k, the coordinates of the endpoint, the restrictions on the radicand, the domain, and the range. We have the function y equals 3 times the square root of x minus 1 plus 4. Let's state the values of a, b, h, and k. We have a equals 3, which is a vertical stretch factor of 3 about the x-axis. Our b value, there is nothing being multiplied to the x under the root, so it's just 1, so there's not really any horizontal stretch factor. We have an h that is equal to, if it says x minus 1, then h is opposite, so x is plus 1, which represents a horizontal shift or translation of 1 unit right. And then we have k equals 4, which is a vertical shift or translation 4 units up. Let's start with our base function and then do some transformations using mapping notation. So I'm going to draw a quick sketch of my base function, square root of x. I know it has an endpoint at 0, 0, and then it goes to 1, 1. Square root of 4 is 2, so point at 4, 2. Square root of 9 is 3. There's our base function, y equals square root of x. Now let's transform those points on that function using mapping notation, and then we can graph our transformed function. Starting just with the basic, so x, y, mapping notation, we have a b value of 1, so nothing being multiplied to the x, and an h value of 1, so it's going to be x plus 1. We have a vertical stretch factor of 3, so 3 times y, plus 4, our vertical shift is up 4. Now let's apply this to our points. We have 0, 0, our end point is going to go to 0 plus 1, and then 3 times 0 plus 4, which gives us 1 and 4. can plot a point. 1, 1, 2, 3, 4. There's my end point. Then we can do the next one was 1, 1. 1 plus 1. 3 times 1 plus 4 gives us 2 and 7. X equals 2, y equals 2, 4, 6, 7. Next point is 4, 2. We get 4 plus 1 and 3 times 2 plus 4, which gives us 5, and 6 plus 4 is 10. 1, 2, 3, 4, 5, and 2, 4, 6, 8, 10. And then the point 9, 3 goes to 9 plus 1 and 3 times 3 plus 4, which gives us 10, and 9 plus 4 is 13. 10, and this was 10, 11, 12, 13. So our transformed function looks like this. This is y equals 3 square root x minus 1 plus 4. This is our end point, and it is at 1, 4. State the values of a, b, h, and k. We did that. The coordinates of the endpoint. We did that. The restrictions on the Radicand, and then the domain and range. So putting our endpoint in here, that's 1, 4. Restrictions on the Radicand. The Radicand has to be greater than or equal to 0. What is the Radicand in this case? It's the thing under the square root, so x minus 1 has to be greater than or equal to 0. We want to solve that for x, so we'd have to add 1 to both sides. And we get x has to be greater than or equal to 1. That's the restriction on our Radicand. Next is domain, x such that, well, on the original function, square root of x, x has to be greater than or equal to 0. Looking at the endpoint on this transformed function, the first x value is 1, so x has to be greater than or equal to 1, x, e, r. The same as the restriction on the Radicand. Range, y such that in the original function, y has to be greater than or equal to 0. Looking at our transformed function, the lowest y value is 4, so all the y values are greater than or equal to 4. Y greater than or equal to 4, y, e, r, close the brackets. Next one, f of x equals -2 times the square root of -1/4 times x plus 1. Outside the root is subtract 3. Start with our parameters. A equals -2. That represents a vertical stretch factor of 2, and reflection about the x-axis. B is -1/4, which represents a horizontal stretch factor of 4. Remember, it's the reciprocal for the b value. And also reflection about y-axis in this case. H value, we have x plus 1, so h is -1, which means a horizontal shift or horizontal translation, 1 unit left And then we have k equals -3, which is a horizontal shift or horizontal translation, 3 units down. Let's use mapping notation. In general, a point xy on the original function square root of x would be transformed in the following way. The x values have a horizontal stretch of 4 and a reflection about the y-axis. So they would be -4x, and then they have a shift left 1, so -1. Y values have a vertical stretch of 2 and a reflection about the x-axis. So -2 times y, and then they have a horizontal shift down 3, subtract 3. Let's apply this to the points of our base function, y equals the square root of x. The endpoint is 0, 0. Sub that in, -4 times 0 minus 1, -2 times 0 minus 3. That would give us, that's 0, so -1 and -3. You can plot that point, -1, -3. Next point is 1, 1. -4 times 1 minus 1, -2 times 1 minus 3, which would go to -4 minus 1, -5, and then -2 minus 3, -5. So -2, 4, 5, and -2, 4, 5. Let's do the point 4, 2 from the original function. Transform it, -4 times 4 minus 1, -2 times 2 minus 3, and we get -16 minus 1 is -17, -2 times 2 is -4, minus 3 is -7. And that's not going to fit on my graph. So I have my end point and I have my first point. I'm just going to attach those to make my graph. This is our end point, which is at -1, -3. Let's fill in the information below. Endpoint, -1, -3. Restriction on the radicand. Let's take our radicand, which is -1/4 times x plus 1. That has to be greater than or equal to 0. I want to isolate the x, so I would need to start by multiplying both sides by -4. When you multiply or divide an inequality by a negative, you have to switch the sign. This is going to divide to 1. We have x plus 1, and then the sign has to flip. Is less than or equal to 0 times -4 is still 0. We're going to subtract 1 from both sides. X has to be less than or equal to -1. That's our restrictions. If we look at the graph, x is at -1 and below, so x is less than or equal to -1. That would also determine our domain, x, such that x is less than or equal to -1, xer, close bracket. And the range, y, such that y is less than or equal to, looking at our y values, we have -3 is our biggest. So they're all less than or equal to -3, YER. What do you notice about the coordinates of the endpoint? If we look at our two different functions, our endpoint was 1, 4 in the first one, and our h and k values were 1 and 4. And then in the second one, our h and k values were -1, -3, and our endpoint is -1, -3. So what we should notice is that the coordinates of the endpoint are the h and k values. So our endpoint is the point h, k. How can we determine the domain/range using the function and the coordinates of the endpoint? The domain is defined by the x value of the endpoint and the sign of b. If b is positive, the domain is x greater than equal to h, which is the x value of the endpoint. If b is negative, the domain is x is less than or equal to h. And similarly, the range is defined by the y value of the endpoint, or the k parameter, and the sign of a. If a is positive, the range is y is greater than or equal to k. And if a is negative, the range is y is less than or equal to k. We can see this with our two functions above. In the first one, we have a positive b value and h is 1. And our domain is x is greater than or equal to 1. Then for the range, we have a positive a value and k equals 4. And the range is greater than or equal to 4. And in the second graph, we have a negative b value and h equals -1. So the domain is less than or equal to -1. And for range, we have a negative a value and k is -3. So the range is less than or equal to -3. Consider the graph of y equals f of x shown below, which is a transformation of the graph of y equals the square root of x. Write an equation for f in the form y equals a times the square root of x minus h plus k. What we should notice here is there's no b value, so no horizontal stretch factor. So we need to find the values for a, h, and k. Well, on the last page, we just discussed how the endpoint is the same as the values of h and k. Thinking about our original function, it has an endpoint in 0, 0. Our new one is up 2 and to the right 5. That provides us with an x value of 5 and a y value of 2, which is our h and k values. We can sub those into our function. Y equals, we don't know a, bracket x minus 5, and then outside the root is plus 2. Now we want to solve for a. We have enough information that we can do this algebraically using our function. We can find another point that's on the graph and sub that into our function for x and y, and then solve for a. Looking at my graph, I see that there's a point at 6, 4. I'm going to sub that in. My y value is 4 equals a, bracket 6 minus 5, and then plus 2 outside. Then I want to simplify. We have 4 equals a square root, 6 minus 5 is 1, and then plus 2. 4 equals, square root of 1 is just 1, and 1 times a is just a, plus 2. And then we want to subtract 2 from both sides. So a would equal 4 minus 2 is 2. Once we have our a, our h, and our k, we can write our function. Y equals a, which is 2, square root x minus 5 plus 2. There's the equation for this function in the form a square root x minus h plus k. Next part, write an equation for f in the form square root of b times x minus h plus k. So this time we have no a value, which means no vertical stretch factor. Same idea though, we already know h and k, we want to figure out b, we can use the same process. We have y equals square root b bracket x minus 5 plus 2. We can sub in a point for the x and y values. I'm going to use the same point, 6, 4. Y is 4 equals the square root of b bracket x is 6 minus 5, then plus 2 outside. Then we want to simplify. 4 equals square root of b times 6 minus 5 is 1 plus 2, so we get 4 equals square root of b plus 2. Next I want to subtract 2 from both sides. And we get 4 minus 2 is 2 equals the square root of b. And then we want to square both sides. And squaring and square rooting undo each other, so we're left with b equals 4. And we know that it's a positive 4 because if we look at the direction that our graph is going, it's the same as the direction of the original y equals square root of x. So there's been no reflections, so we would know that a and b are both positive. Okay, now that we have b, we can write our equation. Y equals square root of 4 bracket x minus 5 close bracket plus 2. Part C. Are your equations in A and B equivalent? Let's take a look at the equation we just were working with. Y equals square root of 4 x minus 5 plus 2. We can split up our radicand into 2 separate radicals. So we can write this as y equals the square root of 4 times the square root of x minus 5. And then we have our plus 2. What is the square root of 4? It equals to 2. So we get y equals 2 square root x minus 5 plus 2. And look, that was our equation from part A. So yes, they are the same. Consider the function described by f of x equals 1/2 times the square root of 1 over 16x minus 1. Describe the transformations that occur if the original function is y equals the square root of x. First thing we should notice is that we don't have brackets. We have a b value, and then we don't have a binomial brackets after the b value. So that means we are going to need to factor that b value out from everything underneath. And then it would become f of x equals 1/2 times the square root of 1 over 16 bracket, and then x minus what is 1 divided by 1 over 16. We can pull up our calculators. One divided by bracket 1 divided by 16 is just 16. Becomes x minus 16, close bracket. So that's our function that we're working with. Now describe the transformations that occur if the original function is y equals the square root of x. We have an a value equal to 1/2. That's a vertical stretch factor of 1/2 about the x-axis. We have a b value equal to 1/16, which is a horizontal stretch factor of 16. Remember, it's the reciprocal, the b value, and then the stretch factor are reciprocals of each other about the y-axis. And then we have an h value, h equals to 16. It's x minus 16 in the function, so the h value is 16. And this is a horizontal translation of 16 units to the right. Part B, write the equation of the function in the form y equals a times the square root of x minus h. So what we want to do is, instead of having a b value, we want to take the b value out from under the radical sign and turn it into an a value. Starting with our original, y equals 1/2 square root 1/16 x minus 16. We want to take this part and bring it out. So like we did above, we can write our radicand in two separate parts. 1/2 times the square root of 1/16 times the square root of x minus 16. Then we can evaluate this part. The square root of 1/16 is 1/4. The square root of 1 is 1. The square root of 16 is 4. So we get y equals 1/2 times 1/4 times the square root of x minus 16. And then we multiply the two fraction coefficients together to get y equals 1/2 times 1/4 is 1/8 square root of x minus 16. That's our function written with an a value and without a b value. Part C, write a function of the function in the form y equals square root of b x minus h. This time we want to have no a value, so the a value that was there in the original, we want to move it underneath. Starting with the original, 1/2 square root 1/16 x minus 16. We want to take this part and move it underneath. Well, to move something underneath a root sign, you have to raise it to the power of the index of that root. So this is a square root, so we have to square the 1/2 to bring it underneath. So we'd have 1/2 to the power of 2 when we move it underneath. 1/2 to the power of 2 is 1/4. We get 1/4 times 1/16 x minus 16. And then using our calculators, four times 16 is 64, so we get y equals the square root of 1/64 times x minus 16. And there is our function written with just a b value, no a value. Part D, what can you conclude about the graphs and corresponding equations of g and h? Well, the graphs and the equations are the same. And equations of g and h are equivalent. So even though they look different, they're actually equivalent. which means a vertical stretch factor of 1 over 8, our A value of 1 over 8 from part B, and a horizontal stretch factor of 64 are equivalent. So in part C, we have a B value of 1 over 64, which means a horizontal stretch factor of 64. And in part B, we have an A value of 1 over 8, so a vertical stretch factor of 1 over 8. Those two things would be equivalent since we didn't change anything about the equation, we just moved numbers from inside or outside the radical sign. Write an equation of a radical function if the following transformations are applied to y equals the square root of x. State the domain and range. Vertical stretch factor of 2 about the x-axis. Horizontal stretch factor of 3 about the y-axis. Translation of 4 units left and 1 unit up. So we have our A value, vertical stretch factor of 2, A equals 2. Horizontal stretch factor of 3 gives us a B that is the reciprocal of 3, so 1 over 3. Translation of 4 units left means that H equals negative 4, and then 1 unit up means that K equals positive 1. And we can write our function. It's a radical function, we know that, so we have f of x equals the A value, 2, then the root, then the B value, 1/3, then bracket x minus h, but in this case it's x minus negative 4, and then plus the k value outside the root. So we can simplify this part here. This means plus 4. Minus negative 4 is plus 4. So our simplified function is f of x equals 2 square root 1/3 x plus 4, close the bracket, plus 1. Let's just put a note here. The brackets around x plus 4 are important. So make sure you put those brackets. If you don't put the brackets, then it means that you're going to have to factor out your 1 over 3 from the radicand, which would change the value of h from negative 4 to something else. So if the value of h is negative 4, we need to make sure that we have these brackets so that b is clearly 1 over 3, which is separate from the x plus 4, showing that h is negative 4. As we saw earlier, the domain is defined by the h value and the sign of b. Since b is positive, then x is greater than or equal to the h value, which in this case is negative 4, and xer, and then close the curly bracket. And similarly, the range is defined by the k value and the sign of a. Since a is positive, y is greater than or equal to 1, the k value, and y is an element of the real numbers, and then close the curly bracket. B, vertical stretch factor of 3 about the x-axis, horizontal stretch factor of 1/2 about the y-axis, reflection in the x-axis and the y-axis, and translation of 6 units to the right. So a vertical stretch factor of 3 would tell us that a is equal to 3. A horizontal stretch factor of 1/2 would tell us that b is equal to 2, the reciprocal of 1/2. But then we have reflection in the x-axis, tells us that a is negative, and also in the y-axis, which tells us that b is negative, and then a translation 6 units to the right that tells us that h equals 6. So putting our vertical stretch factor and reflection together, we get A is -3. And putting our horizontal stretch factor and reflection in the y-axis together, we get that B is -2, and then we also had that H equals 6. Our function then becomes f of x equals -3 square root -2x minus h, which is x minus 6. There's no k value, so this would be it. Remember to have those brackets around the x minus h part. There's our function. Now we want to do domain and range. So our end point would be h and k. There is no k, so in this case, k equals 0. For the h and k values, if it's not written, then it means that it equals 0. So our end point would be 6, 0, which also helps us to define our domain and range. Domain x such that, now, x greater than equal to or less than equal to. Looking at the b value, it's a negative. If the b value is negative, then it's going to be less than or equal to, and then the h value from the question. So x is less than or equal to 6. X is an element of the real numbers. Same for range. Y such that y is greater than, equal to, or less than equal to. If the a value is negative, then y is going to be less than or equal to the k value, which is 0 in this case, and then y is an element of the real numbers. A company estimates its cost of production using the function c equals 20 times the square root of n plus 1,000, where c represents the cost in dollars to produce n items. Graph the function on your calculator and sketch it below. Let's start with that. Y equals, clear what we have there. I'm going to enter the function, which was 20 times the square root of n, which we'll call x, and then get out of my square root and add 1,000. Now thinking about my numbers, I have pretty big numbers, so chances are I'm going to need to have a big window. I can try zoom fit, number 6, and it gives me some idea. I don't see the end point though, so I probably want to go down a bit. So my window, x min is -5, x max is 10, y min is 1,000, and y max is 1,063. I'm going to change my y min to 0, and then I'm going to change my y max to maybe 1,500. I know that my y-intercept, from my equation, my y-intercept is 1,000. So I'm going to change that y max to 1,500, and I'm going to count up by hundreds on the y-axis. Let's try that. So let's do a quick sketch. Our y-intercept is at 1,000. I'm not going to really find any points for this. I know it starts at 1,000 at the y-intercept, and then it just kind of goes up from there. Part A, describe the transformations represented by this function as compared to c equals the square root of n. So if c equals the square root of n is the original function, and then c equals 20 square root n plus 1,000 is our transformed functions. What transformations did we do? Well, we have 20 times the radical, so that's our a value. A equals 20, which is a vertical stretch factor of 20 about the x-axis. And then k equals 1,000 because we have plus 1,000 outside the root, which is a vertical translation up 1,000 units. Part B, what is the expected cost to produce 12,000 items? Well, N is the number of items, so we can sub that in. C is cost equals 20 times the square root of the number of items, which is 12,000 in this situation, and then plus 1,000, and we can calculate. Hit exit, go back to our calculating screen. 20 times the square root of 12,000, get out from under my square root, plus 1,000. So we get the cost would be $3,190.89. State the domain and range of C equals 20 square root n plus 1,000. Our endpoint we know is x equals 0, y equals 1,000, which is also our h and k values. Our a is positive and our b is positive 1, so it's going to be x greater than equal to and y greater than equal to. Domain x such that x is greater than or equal to the h value, which is 0, and then xer, close the brackets. Range y such that y is greater than or equal to the k value, which is 1,000, and then yer. What does the y-intercept represent within the context of this question? So thinking about the question, this is our n values, which is number of items produced. And this is our C value, which is cost to produce n items. So at 0 items produced, the cost is still $1,000. So it's saying that there's an initial cost of $1,000. Okay. This is with no items produced. That brings us to the end of Chapter 2, Lesson 1.